Hi, Assalamualaikum. I am Tengku Zulkarnai bin Tengku Masril Azwan, and today our group will talk about gas chromatography, and I will start this presentation with introduce. So, first, first we will look objective of this project. Objective of this project is to study the bioactivity constituents of S-column-Babiria ethanol extract by cytochemical screening and gas chromatography mass spectrometry, or we call GCMS. And next, to identify the general principle and concept of gas chromatography. Okay, for this, what is chromatography, or we call GC? GC is an optical technique used to spread the chemical component of a sample mixture and then detect them to determine their presence or absence and how much is present. These chemical components are usually organic molecules or gas. Okay, this object or this item is the GC or gas chromatography. What is the principle of gas chromatography? The sample solution injected into the instrument is transported into a gas stream, which carry the sample onto a separator tube known as column. A column spread the various components. The detector counts the number of the components then exits the column. Standard sample with known quantities were introduced into the equipment to measure sample with unknown amount. And to calculate the concentration, the standard sample peak retention times an area where compared to the sample test. Okay, next we will look what is the principle of separation in GC analysis. Okay, the separation of the compound is based on the different range of interact of the compounds with the stationary phase, like dissolved light. The stronger the interaction is, the longer the compound interaction with the stationary phase, and the more time it takes to migrate through the column. It means longer retention time. It means it will take longer retention time. In example, compound X interact stronger with the stationary phase and therefore lags behind compound O in its movement through the column. As a result, compound O has a much shorter retention time than compound X. Next, we will look what is the component in the main component in the GC and what is their function. So there are three main GC system component, which is first, sample injection unit, which heat the liquid sample and vaporize it. Next, column, which is used to separate each compound. And next, detector, which detect the compound and output their concentration as electrical signal. Okay, next we will look how GC work. Okay, next the sample and the carry gas are heated and will enter the column. In this column, why the tube is too long is because we want a better separation of the component. And after at the end of the column, the detector will record the amount of the sample hitting it, and the end our computer will show the result data.
Assalamualaikum warahmatullahi wabarakatuh. My name is Badri bin Kamarudin. I'm from RIS 1205G. Now, I will explain about the methodology of this experiment. For methodology, we have two parts. First is the sample preparation, and second is sample analysis. Sample preparation also has two parts. First is plant collection and plant extraction. First, we go to plant collection. The whole plant of Scambiosa columbabria was collected. Then, the leaf of S. columbabria were detached from the plant. Next, the leaves were washed with clean tap water thrice to remove debris. Then, it was over-dried to a constant rate at 30 degrees Celsius for 1 week. And lastly, the dried leaves were milled to a homogeneous powder using an electric blender. Next, we go to plant extraction. About 60 grams of the powdered leaf was extracted in 100 ml of ethanol. Then, it was placed on an orbital shaker for 24 hours. The extract was filtered using a Buchner funnel and Wattman No. 1 filter paper. The resulting filtrate was concentrated to dryness using a rotary evaporator. The final extract was weighed to determine the yield 4.54% and then stored at 4 degrees Celsius in a refrigerator for further studies. Now we move to sample analysis. The analysis was carried out using an Agilent 7890GC system equipped with Agilent 5977A mass selective detector system with a Zebron 5ms column. The injection temperature is 250 degrees Celsius. Then, the ion source temperature is 280 degrees Celsius with the pressure at 48.745 kilopascal. The carrier gas used is helium gas at flow rate of 36.262 cm per second. The sample injection about 1 microliter was used. And lastly, the oven temperature was initially start from 40 degrees Celsius for 1 minute and then ramped to 240 degrees Celsius at 3 degrees Celsius per minute.
Hi, my name is Uwaish bin Fauzi, and I will talk about the discussion to this study. To investigate the importance of any medical plant, the initial step is to screen for its cytochemical, as it gives a broad knowledge with respect to the nature of the compound present in it. In the present study, the ethanolic leaf extract of S. columbabria were primarily screened for the cytochemicals. The X-ray shows the presence of alkaloid, flavonoids, phenolics, terpenoids, and sapphonoids. These observed cytochemical have been reported to pose a broad range of activities. For example, alkaloids present in the extract have been reported to pose anticonvulsant, hypotensive, antimicrobial, antiprotozoal, and anti-malaria activities. In addition, studies has also shown that plant with alkaloid may have hypoglycemic effect via insulin-releasing mechanism and insulin mimicking activity, thus improving the proprandial hyperglycemia. The presence of flavonoids in plant extract has also been reported to play an important role in plant biochemistry and psychology as enzyme inhibitor, antioxidant, antidiabetic, anti-inflammatory, antimicrobial, antifungal, and anti-cancer activity, thereby protecting the cell against all stages of carcinogenesis. It can be observed from this study that the presence of alkaloid, flavonoids, phenolic, tannins, steroid, terpenes, and saponid in the extract of S. columbabrea leaf is in support with those reported indicating the presence of this cytochemical in the plant extract. Therefore, this cytochemical observed in the ethanol leaf extract of S. columbabrea are an indication that this plant play a vital role as a dietary antioxidant, and it can be used to develop new compound for health benefit. The result of the GCMC analysis of S. columbabrea revealed the presence of 16 compounds like shown in Figure 1 and Figure 2, representing 100% of total identified component. The detected compounds class were mainly composed of alkyl glycerol, coumarins, diterpenes, ester, flavonoids, monoterpenes, steroids, phenols, and others. The most represented chemical class were flavonoids 40.84%, steroids 14.06%, coumarin 10.45%, alkyl glycerol 6.86%, phenols 2.24%, monoterpenes 1.11%, ester 0.79%, and diterpenes 0.54%. In addition to anti-inflammatory activity, eucalyptus was also reported to be frequently used in the manufacturing of cosmetics, thereby increasing the percutaneous penetration of drug as aromatherapy agent. Benzene 1,4-dichloro, which is one of the main components found in the extract of S. columbabrea, was reported for being used as a deodorant. Cytol, which is a key isolate diterpene class of compound, was identified in the extract and was also reported to exhibit antibacterial activity against Staphylococcus aureus and Escherichia coli by causing enormous damage to the bacterial cell membrane. Beijing et al. Also reported strong antimicrobial activity of cytol by microdilution method against 8 bacterial and 8 fungal strains. In addition to its antimicrobial activity, cytol was also reported to exhibit no remarkable toxicity when treated with mouse skin cell. Branch 5-in-3,20-dione, a steroid, was detected in the extract has been indicated to pose potent antibacterial activity against 15 marine bacterial strains. Batilol was reportedly used in cosmetics as a stabilizing ingredient and skin conditioning agent, while 3,5-dihydroxy 678 trimethylflavone was detected in higher amount, which is 40.84% in the extract, was previously reported to show moderate antifungal activity against Candida albicans with an minimum inhibitory concentration value. However, to the best of our knowledge, this is the first study to identify the bioactive constituents of S. columbabia by cytochemical screening and GCMC. Therefore, it could be concluded that this study that ethanol extract of S. columbabria composed of various bioactive compounds which are known to exhibit various biological activities and may therefore be recommended as a plant of pharmaceutical importance.
Lastly, I will explain about the conclusion. The study shows that ethanol leaf extracts of S. columbabria contain some phytoconstituents which are pharmacologically important, therefore could represent potential source of lead molecules with pharmacological activities for the development of new novel drug or a leading compound for the treatment of skin and other diseases. In addition, the presence of these compounds with biological activities justifies the traditional usage of S. columbabria for the treatment of skin and other diseases. Hence, further studies are needed to isolate individual bioactive compounds as possible for its therapeutic activity and the elucidation for their mechanisms of action. That's all from this video. Thank you.